Okay, looking at our do now for today, we're going to go ahead and just run through this. It says during a summer vacation, we were looking to pick blackberries. They decided the blackberries for jam, and they must cook the blackberries until they become juice combined with other ingredients. So we're going to use the table to determine the constant of proportionality between the cups of blackberries and the cups of juice. So that's our first ask. So when we look at this, we can't really use the 0 over 0. We can use this one, so thinking about this as our x and our y. We can look at the second grouping here. Y over x would be 4/3 over 4, which is the same thing as 4/3 divided by 4, which again is the same thing as 4/3 times 1 over 4, cross cancel, and that gives us a constant of proportionality of 1/3. So it looks like our constant of proportionality is 1/3. Which would give us an equation y equals 1/3 x. How many cups of juice to make the 12? So that's just looking at this over here. They've put that in the chart for us. That means our x is 12. Y is equal to 1/3 of 12, which would be 4. And how many cups of berries to make 8? So that's in the y category. So y is equal to 1/3 times x. So we need to divide by 1/3, which is the same thing as multiplying by the reciprocal, which is 3 over 1. 8 times 3 over 1 is equal to x. So 24 is equal to x. So again, it's that very basic process. Find the unit rate, write the equation, plug in, and solve. Here we have a markup problem. It says after the store marks up the price 2/5 of the original price, the new price is $35. So we don't know the original price when we draw our diagram here. Our original price is an unknown. So the thing that we're finding a fraction of is unknown. We do know that they are splitting it up into 5 pieces. So we're going to pay an additional 2/5 in addition to the, since it's a markup problem, the 5/5 that they originally paid for it. So we're trying to figure out what 1 whole is. So when we're end up paying, we're going to pay 7/5, a total of 7/5 of the entire price. 7/5 of x is equal to the new price, which was 35. So we end up dividing by 7/5. So that's x is equal to 35 divided by 7 over 5, which is the same thing as multiplying by the reciprocal, 5 over 7. And when I do that work, I should get 25. Alright, let's get on with today's aim. Kipsters will be able to determine if a drawing is a scale drawing. So today we're going to cover a handful of vocabulary that we definitely need to know. So we're going to start by looking at these two pictures. The question asks us, for the following problems, is the actual picture A and the drawing B, is the drawing an enlargement of the actual picture or a reduction? So this is where our vocabulary comes in. We need to make sure we understand what the word enlargement means and what the word reduction means. think about the etymology of those words. Enlargement, we see the word large as part of the base word there. En meaning to do something. So we're going to make something larger. So is this an enlargement or a reduction? We see the base word on reduction being the word reduce, which we know should mean to make smaller or to minimize. So when we're looking at this, enlargement means to make larger, reduction means to make smaller. So when we look at this, we're going from A to B, we're making it larger, which means this is an enlargement. And we go from A to B, we're making it smaller, which means this is a reduction. Now when we're talking about enlargements and reductions, we always talk about keeping them in scale. So what does it mean for something to be in scale? Well, if we look back up here, particularly when we're talking about scale drawings, a drawing that all links between the figures are reduced or enlarged, so we're going to see that relationship. Scale drawing is either a reduction or enlargement, but most importantly here we see the word proportional, okay? So the lengths and widths of all of the parts of the drawing are in proportion. So we're going to have to explore and see what that means. We're going to look at this first one. It says Derek's family took a day trip. They went to a public garden. They see a picture of the garden and a map of the garden. The diagram below is the top view as Derek held his map, and this is the posted map that they found. So this is in hand. This is our posted. In order to really determine whether something is a scale drawing of another thing, we need to be able to recognize corresponding points. So I look over here and it kind of looks like V corresponds to R. Take a moment, consider, are those actually corresponding points? Are those the same places in the garden? If they're not at the same places in the garden, how do we know they're not the same places in the garden? So hopefully what you've identified is that they are not the same places in the garden. And what has actually happened is that they have turned the map. Okay, so we can see that in this particular picture, this kind of bullety looking thing has been turned. So it's like they took this entire thing and they have turned the picture 180 degrees. So now we can see that that's where the relationship really is. You can see that N up here, which is on the front of this bullet looking thing, is the same as Y, which is also on the front of this bullet looking thing. So when we're looking down here at our corresponding points, it's important to recognize what corresponding point, what corresponds to what, when we're thinking about trying to measure whether something is proportional or a scale drawing or not. Okay, so we've seen that Y corresponds to N. We need to figure out what corresponds to A. So A is kind of this path that kind of leads us toward the bullety looking thing. So the bullety looking thing is here. So this is our path here to A, and that's R. Go ahead and figure out the other two on your own. Okay, hopefully you quickly identified that H is right here at these crossroads. Same thing as those crossroads there, so that's P. And point V is down here at the bottom. That's underneath the circle, and so that corresponds to, if we kind of flip this around, to see it back where the other way it was. It's at point W. Okay, so that's just an important thing to be thinking about when we're thinking about scale drawings, is that our corresponding points are the points on the same drawing that's either been enlarged or reduced that are in the same place. Now obviously they're going to be different sizes if it's an enlargement or a reduction, but they're going to be corresponding. We use the word corresponding. Alright, so create a scale drawing of your own modern nesting robots using the grids below. So we're going to be looking at trying to create scale drawings of these robots. And we're going to be using these different grids here. So we've got one grid that appears to be smaller and one grid that appears to be larger. So as we get ready to draw them, we're going to be thinking about corresponding parts. So I'm going to be thinking about, where does this piece lie on this grid? So we can see it's the same size grid. So if I want to find the corresponding point, I can count that it is 3 down, and it is 1, 2, 3, 4, 5, 6, 7, 8. 8 over. And once I've gone ahead and done that, 3 down and 8 over, I can pretty much do everything relative from there. So the top of his head is 4 units. And his head goes 4 units down and 1 over, or 4 units down and 1 over. So 1, 2, 3, 4 units down and 1 over. 4 units down and 1 over. And kind of here on his shoulder is 1 unit and 1 unit. Sorry for the sloppiness here. And then his body goes 1, 2, 3, 4, 5, 6, 7, 8, 9 down from his shoulder. 1, 2, 3, 4, 5, 6, 7, 8, 9. And same thing on the other side. And double checking, that should be 1, 2, 3, 4, 5, 6, 7, 8 across. And his legs start 1 in and go 1, 2, 3, 4, 5, 6, 7, all the way down to within 1 unit of the bottom, and are 3 across and up, and 3 across and up. And his arms start 1 unit from the bottom and go over all the way up to his shoulder. All the way up to his shoulder. So here we were able to draw a scale drawing of the robot. And so the question here is, like, did we have to do any calculations? Did we have to change how many units there were to get this enlarged picture? And the answer to that question should be no, because what ended up happening was we didn't have to change how many units it were, because the units themselves were all enlarged proportionally. So one way to create a scale drawing is to simply have a grid where you enlarge the different units to move forward. Go ahead and create a reduction using that same idea. We have a grid that has smaller units where we don't have to do any calculation to figure out how big or how small each length is. We're just going to have the same number of units in corresponding places, just with smaller sized units. As you work on this, I'll go ahead and work on this as well. Alright, so again, I can see that I've made a slightly smaller version of our robot simply by putting the corresponding pieces together. Okay, one last problem to look at here. This is one where we actually do have to do the work. We can see the grids here are of the same size, so the units are all the same, but we can use a constant of proportionality to reduce or enlarge the number of units in a corresponding way. So Celeste drew an outline of a building she was making, and the second one, mimicking the original drawing, state the coordinates of the vertices and fill in the table. So we're going to skip filling in the coordinates here because we're really just looking at the overall height and the overall length. Okay, so the overall height and the overall length of the original building. So this is our original building. We can see that it goes up 18 units. The height is 18 units. And the length is 6 units. And for the second one, we see the height is 9 units. The length is 3 units. And so in order for this to be proportional, we would need everything to correspond, which means that we would have to have a constant of proportionality that is functional for all of these. So if I take this and think about the height as my y, or the x and my y, I have y over x. My constant of proportionality would be 6 over 18, and that simplifies to 1/3. In order for this to be a proportional drawing, a scale drawing, we would need to have the same proportional relationship between the height and the length. And so I want to check, do I have that same relationship? 3 over 9 is 1 over 3. And I do indeed have that same relationship. So that means this is a correctly scaled drawing. Alright, so let's give you one problem to work on your own. Go ahead and flip over to your partner work time. And go ahead and complete that problem on your own. In this problem, you're asked to identify whether the two triangles are proportional or not. And I guide you through by asking you if a constant of proportionality exists. If so, what is it? If not, explain. So they give you a chart up here to help you compare those two things, height and width. And so we're going to go ahead and look at those measurements here. For the first one, I can see that the height appears to be 5, and the width appears to be 3. For the second one, the height appears to be 15, and the width appears to be 10. So when we look at this, they've done an interesting thing here. They've tried to make an enlargement. We can clearly see that we've gone from a smaller to a larger. But when we start to come over here to see that constant of proportionality between the height and the width, we should see the exact same thing. So when I come over here and I do y over x, I'm going to get 3 over 5. And when I come over here, I'm going to get y over x is 10 over 15, which reduces to 1 over 3. 1 over 3 is definitely not equal to 3 over 5, which means that this is not a correctly scaled drawing. So does a constant of proportionality exist? No. The ratio of height to width is not the same. I'm going to just draw an arrow over here to my work. show my proof of that. Is Lucas enlarged in mosaic a scale drawing of the first image? And the answer is no. A constant of proportionality does not exist. What this means is that in some form or fashion it has been stretched or skewed or shrunk or squeezed together in one direction or the other. So it's hard to tell which one was actually done right and which one was actually done wrong. But what we can see here is that a constant of proportionality does not exist. So we should be walking away with three main things in our brain today. One, that we know a scale drawing is either a reduction or enlargement of an original picture that happens in a proportional way. All right. So the importance of matching corresponding points will help us identify where we're going to measure from, and so we can see if corresponding lengths of scale drawings have equivalent ratios. Okay, so length and width must have a constant of proportionality, the same ratio of lengths and widths, if they're going to work out. All right, so go ahead and move on to your independent problem and move on to con thereafter.